this video, we present 3 analytical techniques to reinforce your common sense to make better, defensible decisions. At the end of each technique, simply ask yourself, could I have made better defensible decisions without resorting to analytical techniques such as these? Multi-criteria decision making using the analytic hierarchy process. Most of the decisions we face in the real world are multi-criteria in nature. Typical examples could procurement, recruiting, locating branch officers, etc. The best way to explain this is to consider a hotel chain hiring a business development manager. They identified 6 criteria and 4 candidates. Let us now look at the HP software that we have developed. I have set up the recruiting problem, and when I hit continue, we have the criteria and the candidates that I have already inserted. We move on to the judgment table. The criteria judgment provides a pairwise comparison. All you have to do is remember 2 simple questions. Which one? How much? So the first question is, between availability and leadership, which one is important to you? Availability. Then it's asking availability and salary. You might say salary. You proceed with this. When you finish, you simply say OK, and you hit continue. And you're offered the candidate judgment, which is identical to the previous case. On this occasion, you're offered one criterion with multiple candidates. Once again, we answered the 2 questions. Which one? How much? Which we say which candidate is more important than the other one, and to what degree. We do this for each criterion. When you finish, press OK, and we are presented the criteria weights and the candidate weights. Once we complete the evaluation, we generate a graph using the chart maker. We see that the optimum decision is Mary. Additionally, we have 6 bands. These are known as the N-1 evaluation. Here we have removed availability. Here we have removed leadership. And here we have removed salary, etc. And if salary is not an issue, so far better candidate. Could you have made better defensible decisions relying on common sense alone? Probably not. Single criterion decisions with multiple uncertainties using decision trees and D-zone maps. Gengen Pharmaceuticals are developing a new drug for the treatment of diabetes, thrombosis, and cholesterol. However, Gengen can invest only in one of these projects. The cost of pursuing these products, for the preliminary test, we would spend $2.5 million. And for the FDA approval, there would be a cost of $500,000. The marketing department has arrived at potential revenues from these projects. Here too, there are some uncertainties. There's a potential for high revenue or low revenue. For example, for cholesterol, the high revenue would be $13 million, while the low would be $7 million. Uncertainties facing Gengen are, will the preliminary test be successful? Will the FDA approve the new drugs? Will sales generate the projected revenues? The question for Gengen is, which product? We can start with a 50-50 assumption for all uncertainties, and then study the impact of such assumptions on the final decision. Action plan. First, draw the DT sketch, then develop the Excel model, then plot the D-zone map, and finally study the uncertainties. Here we have the sketch for the decision tree. We have 3 options, and let's focus on thrombosis. If the preliminary tests are successful, then we proceed for FDA approval. And if FDA approval is granted, we proceed to market, and there is a potential for high revenue or low revenue. Similarly for the other 2 projects. Now to step 2, where we build the Excel decision tree, and in this case, it is for the preliminary tests. Once we complete the decision tree model, with one click, we can create the D-zone map. The model creates 3 zones for the 3 decisions: thrombosis, cholesterol, and diabetes. The zone in which the red pointer lands is the recommended decision. Here we have 3 axes. One is for diabetes, the next is for cholesterol, and up here is the thrombosis. When I change the probability of success, the decision is thrombosis. If I change the probability of thrombosis success to 70%, again the recommendation is for thrombosis. What is important to notice is the distance of the pointer from these demarcation lines tells you the degree of freedom you have with regard to your assumptions. In this case, when the probability of diabetes success drops below 46%, the decision should be for thrombosis. Zone map such as this gives you tremendous flexibility to understand the sensitivity of your assumptions to the final decision. We repeat the same process for the FDA approval and the projected revenue, and we can see under all three scenarios, the recommended decision is to proceed with diabetes project. Could you have made better defensible decisions relying on common sense alone? Probably not. Decisions driven exclusively by financial considerations using payoff table. Joe's business is buying and selling premium salad packs. He buys the packs at $20 each and sells them at $40 each. Any packs he cannot sell is sold as animal feed at $2 each. Joe has historical daily sales data for the past 150 days. The daily demand for salad packs are 10, 20 or 30. This is known as the states of nature. The decision that Joe has to make is how many salads should he order per day. The dilemma facing Joe is, should he go for maximum profits? Should he play safe and avoid a loss? What if the probabilities are wrong? Is he willing to give up on profits for safety, or will he regret making the wrong decision? Economists have developed several criteria to analyze these types of problems. Here we have 6 criteria, but which one Joe accepts depends on his risk tolerance.
So let me introduce you to an Excel payoff table that we have built. You should only be concerned with the area that is in gray and these yellow backgrounds. Here we type a problem, here we type the units, here we type the decisions and enter the data. And when we do that, we will get the recommended solution. So in the salad example, here are the historical data and we have the calculation as we indicated. And here we have the profit and loss. Now this is a simple table that I have built when he buys 10, 20 or 30 packs. And the demand under each scenario could be 10, 20 or 30. Here are the sales per day, what is unsold, and the profit and the loss and the net. We can then transpose this information to the form that we would like. So here we have likely demand per day and recommended purchases per day. And this data comes from here. For example, these 3 200s are here and I can simply copy it over here. So now we have all the data we need and we simply look at this red arrow where it shows what we should do based on our risk tolerance.
There is no way you can address the 3 problems we presented here relying on common sense alone. Beware, hubris could lead to suboptimal decisions. If you're still confident that you make good decisions, then try this 4-minute multiple choice skill test.
Train with an emphasis on the 3 M's: the message, the messenger, and the method. We have in-house workshops and public workshops on decision making and negotiating. Do let us know if we can help you. Thank you for watching.